want to talk to you tonight about equations with the ellipse. My goal today is really to be able to give you some suggestions on how to write these equations out in the most efficient way possible. There's a couple of things you have to start out with. Number one, assess what you've been given. If I've been given the vertices or the foci or the covertices, or maybe I'm lucky enough to be given A and B and the center, which is essentially what I need at any point. Knowing which letter goes with which part. For example, I know that vertices, we use A to find the vertices. I'm going to be using C to find the foci, and if I'm looking to find the covertices, I'm going to be using B to get that equation, or to get those values. A number of things that come into play here. Number one is the relationship between A, B, and C. We're going to be using A squared minus B squared equals C squared. I know there's a different way to write that. You could say A squared equals B squared plus C squared. I tend to write it equal to C squared because I'm looking to find C most of the time. And in this case, we're going to be starting out with our vertices. I want to call your attention to looking at what you're given. In a lot of cases, vertices and foci are going to share a few things. Number one, I can tell you that they share one coordinate. In this case, the vertices and the foci share the y coordinate. Means that they're going to exist on the same y value, right? So if it had it here or here, they're going to share the same y coordinate, which means they're all going to be on the same horizontal line, right? So the vertices would be here, and the foci would be just inside those in some respects, right? Which means that my major axis is horizontal, all right? I look at that and I think, okay, which variable, which coordinate, x or y, is changing? If I look at the vertices or the foci, I know that they're on the same axis. I can look at those and I can say that because they're the same, I can tell you that that's what's going to be going on. Anyway, that's step one. Look at what's changing. That's going to give me, for center, I know that I'm going to have something, comma, 5. I know because the center lies within the middle of that. And I know I'm going to have a minor axis that goes like this. Now, I'm not trying to graph it today, so I'm not really going to take the time to do that. However, if you'll take a second, if you're given anything that looks like this, where you have a coordinate plus or minus some radical thing, right? You can see that in several of these, right? You can see that in both the vertices and the covertices in this example right here. So, right, so you have 3 and then -1 plus the radical here, and then 3, -1 minus the radical. Interestingly enough, I have the same kind of situation happen. I have the 3 plus something, the 3 minus something, and I have the -1 for the y coordinate. If I look at some of these others on this page, I can come down here and I can say, look at the foci. Here it's 2 plus the radical, -8, then 2 minus the radical, and -8. And I have a coordinate that repeats, right? It has the same x coordinate. The foci here, the endpoints of the major axis, by the way, these are my vertices. That's just another way of calling vertices. I can see that they do share a single coordinate here, right? They share the coordinate of -10 for both of them. So with the radical in the example I showed you in number 3, like this one, as well as the one over here in number 1 and 2. Let's take 2 for a second. This is giving me the center of my equation every single time I'm been given any kind of situation where I'm looking at the radical, right? I can tell you here the center is going to be 3, -1, right? And I can see that in this one really easily because I have a 3 and a -1, a 3 and a -1, 3 to -1, 3 to -1. I'm looking for, if I could just delete the radical part of that, I'm kind of given a little bit of a shortcut, a little bit of a glimpse into seeing the center of the equation. Let's go back to number 1 and do the same thing. I can tell you my center is going to be -9 and 5. Now, I could take this in a more of an algebraic approach. I know that the midpoint between the vertices or the foci or the covertices, the midpoint So add the x's together, divide by 2, add the y's together, divide by 2. If I use the midpoint formula, I'm always going to be given the center. It's the midpoint for both axes, right? So that's one thing you can do. The next thing is to realize that when I've been given that plus or minus the radical part, if I'm dealing with vertices, I've been given A, which is what we have here. That's going to be A. In this example here, that's A. In this example, where I'm adding and subtracting, this one's going to be B because the covertices deal with finding B. So let's take that example and kind of, number one, and write out what we need. I know that I have a horizontal major axis because I've drawn that picture. The X is what's changing, so that's the way the major axis runs for vertices. Same thing for foci. So I'm going to write the general equation down. So it's X minus H squared over the A squared because it's the major axis is horizontal like the X axis plus Y minus K squared over B squared, which is equal to 1. If I have the center A and B, I have everything I need, and that's guaranteed in every example. If you can get center HK, A and B, you're done. Okay, make sure you know which equation you're working with, but other than that, you're done. Let's plug in what I know already. It's going to be X minus -9 squared over A squared. Well, I know what A is. A is the square root of 185, so I'm going to square that. 185 plus Y minus K, well, K is 5, squared over B squared. I don't have B squared yet, right? That's the one thing I don't have. So if I'm pushed to move on, I just found 75% of the problem. And I mean, don't get me wrong, finding B here is not a hard task. I'm going to go ahead and plug it in, right? I know that if I can tell you how far is it from the center to the focus, then I've got it. Or if I wanted to use the distance formula, the distance from the foci to the other foci is going to be 2 times C. Well, how far is it from -4 to -14? Because that's the one that's changing. So the distance between the two of them, well, that's 10, right? Right. If I say -14 and I add 10 to that, I'm going to get to -4. Or if I subtract the two, -14 minus -4, I'm going to get a -10, but we're talking about distance here, so it's always positive. So I know there's a difference of 10 units here. That means that my C is 5. Okay, and so the way we work this out is we're going to go back to our equation up top. It's going to be 185 minus B squared is equal to 5 squared. Just again, to refresh your memory, what I did here was I said -4 minus -14. I took the part of the foci that was changing, right? And I just subtracted the 2. You can use the distance formula as well, but that's a little bit of an overkill, right? And so when I do that, I'm going to get 10. Remember, this is equal to 2C. That's how far it is between the foci. If I were using the vertices to do this, then that would be 2A. If I were using the covertices to do this, it would be 2B. And then I just divide that by 2, and I get that C is equal to 5. And then I'm going to work this out. We're going to have 185 minus 25. That's going to be equal to my B squared. Now remember, I don't really care about taking the square root of B. I just want B squared, right? So if I subtract this, we're going to get down to 160 is equal to B squared. And that's the only thing I needed, right? So 160 is going to go right there. And then we end up with our final solution. Now, it took a long time to discuss that. It took almost 10 minutes to do that. And that's not nearly as long as you need, or it's way too much time. But I want to kind of talk about this at the beginning and give you guys a really clear picture of what all is out there, and you kind of grab on to what sinks in and make sure you can do these fairly well. Let's go on to the next question. I'm going to kind of move a little bit faster now. I'm going to go ahead, since I've already got the center laid out, I'm going to tell you that my A is going to be 2 square roots of 30. My B is equal to 2 square roots of 10. Now remember, if I have HK, A, and B, and I know the orientation, I'm pretty much done. Let me square these two, right? A squared, well, this is a little tricky. 2 times the square root of 30 squared. Remember, when you square a radical and a number, square the number. square the radical, which basically cancels the radical, and simplify, right? So this is going to give me 4 times 30, or 120. For b squared, we're going to do 2 square roots of 10 squared. That's going to be 4 times 10, which is going to give me 40. Now, here again, looking at the vertices, just like last time, if I look to see which which coordinate's changing, right? So it looks like 3 is the same. So for all the 2 vertices are going to have the same x-axis, x value, right? So there's a vertex, and that's a vertex, and that's on the same value of 3 on my x-axis. That means that my major axis is running vertically because the y value in this case is changing. And so I know that I'm going to need this generic formula. It's going to be x minus h squared over b squared plus y minus k squared over a squared. Remember that in this example, in the ellipse, a is always greater than b. A represents the value that I'm using to find the major axis, the vertices. It's always going to be bigger. Okay, so obviously we're just going to plug everything in and we'll be done. So it's going to be x minus 3 squared over the b squared. In this case, that was 40 plus y minus negative 1 squared over a squared. In this case, it was 120. That's equal to 1, and that's it. Okay, let's keep going. Number 3, this one is, if I get there. Number 3 will give us the foci. Remember, the foci and the vertices all are on the same kind of similar axis. They're on either on the major axis. And so I can tell you my center. It's nice that we have one of those radical symbols here. It's the 2 and the negative 8, right? I can see that in those places. And so we have the center of 2, negative 8. Here again, if I didn't remember that, the midpoint formula always works. I can tell you that C is 3 square roots of 11. To find my B, I take the covertices and I'm going to subtract the changing coordinate. And so we're going to say negative 7 minus negative 9. So that's going to end up giving me negative 7 plus 9. So I'm going to get 2. We're going to get 2 equals 2b. Remember, the distance between the covertices is twice b. So divide by 2. That's going to allow me to find that b is equal to 1. That's always nice. All right, so we have c, we have b. Let's find a. So a squared is equal, or a squared minus b squared equals c squared. Remember, this is not the Pythagorean theorem. So let's plug it in. A squared minus b squared, which is just 1, equals c squared, which is going to be 3 square roots of 11. And so we'll square that whole thing. That's going to be 9 times 11, or 99. Which means I'm going to get a squared is equal to 100. I've got everything I need. Let's go ahead and write this down. And so we know that my foci, I'm looking at the coordinate that's changing. All right, if I had a focus here, I'm going to be adding and subtracting an x coordinate, which means my foci are going to be horizontally apart, which means the major axis runs horizontal. So we're going to need the general equation x minus h squared over a squared, because the major axis runs like the x-axis. And we're going to have y minus k squared over b squared equals 1. Let's plug everything in. We're going to have x minus 2 squared divided by a squared, which is 100. Then plus y minus k, which is negative 8 squared, divided by b squared, which is just 1, which is equal to 1. Now, the 1 here at the bottom, this is not technically required. You are welcome to keep that if you want to keep it in there, but typically I tend to write that value down, which is totally fine. But if you do not want to, it is up to you. Okay, let's keep it going. Here again, going to kind of run a little faster here. I'm going to tell you that my center is going to have an x-coordinate of -10. And I want to figure out what's the midpoint between these two values. Here's one of the first times where I don't get the center right off the bat, but I can find the midpoint in these two values, right? And so let's just do the whole midpoint formula. So it's going to be -10 plus -10 divided by 2. That's the x-coordinate, which you already knew that one. And it's going to be 4 plus -2 all divided by 2, which gives us -20 over 2. And we're going to get 2 over 2, which turns out to give us -10, 1 as my center, right? This is where we'd use the midpoint formula to kind of, and I could have used that with either the major axis endpoints, which are the vertices, or I could have used it with the foci, because it's always the center of everything, which is why we call it the center. Okay, we know that the A value is the distance from the two different vertices, right? So this distance to this distance. So I'm going to take the coordinate that's changing. I'm going to subtract them, right? So 6 minus -4 is equal to 10, which is 2a. Those coordinates are 2a apart, which means a ends up being 5. We're going to do the same thing with the foci. This is going to allow me to find c, right? I'm going to say 4 minus -2 divided by 2. To finish out to finding c, we're going to subtract and then divide by 2, and that's going to give me my c value, which in this case is 6 divided by 2, so 3 is equal to c. All right, so I found out the distance between the two was 6 units apart. So you divide the 2, you get c equals 3. So we're going to have 25 minus b squared is equal to 9. So b squared ends up being 16. Okay, so we've got everything. Let's figure out the orientation. We've got my center, we've got my a, and I've got my b squared. So we know that the major axis endpoints, the vertices, have a y value that's changing, right? So they're vertically apart from each other. Oops. Yes, that's right. They have the same x-coordinate, right? So we know we have a major axis that's going to be a vertical axis. So we're going to have x minus -10 squared. Now b squared is going to go under here, so 16, plus the y minus 1 squared over 25. And that's equal to 1. Okay, so there's the front page. Hopefully that cleared up a few things there. Let's go on to the last two questions. Okay, no, last 3 questions actually. We're back to one where we've got lots of radicals. I really like these. That really helps out a lot. The major axis is running the, which one is it? So 8 is the same, so it's the same x-coordinate. So we have changing y-coordinates, right? So we have a major axis that runs like this. So I have a, nope, back that up. The y value is changing. So it just said that. All right, so these are both 8s, and then the y values are changing, so I have a major axis that runs vertical. Center, that's just going to be 8, -4. This example, I can see that both 8, -4 here and here, and there, and there. Endpoints of the minor axis, these are also called the co-vertices, right? And the endpoints of the major is called the vertices. Just another way of naming them. I also can tell you that a in this example is 5 square roots of 7. B is the square root of 65. So b squared, which is nice, is 65. A squared is going to be 25 times 7. So that's what, 140, 175. I believe that's correct. And so that's going to be equal to a squared. That's everything I need. I'm going to be using x minus h squared over b squared plus y minus k squared over a squared. I know that's that case because I know that the major axis is a vertical axis. So a goes under the y. Here again, it's going to be x minus 8 squared over 65 plus y minus negative 4 squared over 175 equals 1. This one was nice. It gave me the vertices and covertices, which allows me to find A and B relatively quickly. And it had the radical involved, so I got to see the center almost instantly as well. Let's keep on going. Number 6. So this one, if you look at it, what it tells me, center, right, off the bat, they give me HK. That's really nice. If I graph that center just as a rough sketch, 0, negative 6 would be here. So there's my center. What I'd like to get an idea is I'm looking at the coordinates, right? Another way of doing it versus just looking at the numbers is I'm going to graph the vertex as well. So I'm going to go out to 6 here and down to negative 6. So I've got a vertex here and a center there. It means that this is going to be going like that. So the major axis is going to be running horizontally. So I know that the distance between these values, this one and this one, this is your A value, which is also 6. The focus, they give us the other side of the focus. It's back this direction here, right? It's a negative 2 square roots of 5. But the distance from here to here, we call C. In this example, that's 2 square roots of 5. The last thing we need to do is to find my B value. And we're going to say it's going to be 36 is equal to, no, I always say it's A squared minus B squared equals 2 square roots of 5 all squared. So we get 36 is equal to, this is going to be 4 times 5, so it's going to be, let me back that up. We're going to say 36 minus b squared is equal to 20. So really I'm going to subtract 20 from both sides and add the b squared. So we're going to get 16 is equal to b squared. Okay, and so basically I'm going to write it out. It's going to be x minus 0, or you could just write x squared here. And that's going to be over 36. Because it's 6 squared. And then we're going to plus y minus negative 6 squared divided by the b squared, which is 16, and that's going to be equal to 1. Okay, I think the graph is probably the easiest of everything. I can tell you the center looks right here, right? You can find your minor axis here. Your major axis is here. Where they cross over, you got your center, right? So center is going to be equal to 0 for x, because I don't go left or right at all, but I go always down to negative 3 to get the center, right? I can tell you that A goes from 0 all the way out to 7, and that B goes from the center and it goes up 1, 2, 3 steps. I could find C if I really wanted to, but remember, I don't need to. I've got a horizontal graph, which means I have a horizontal major axis. So it's going to be x, or use just x squared in this example, divided by 49, because it's running like the major axis, like the x-axis, plus y minus negative 3 squared over 3 squared, which is 9. That's going to be equal to 1. And this concludes our graphing, well, our equation writing session. Take some time, look back at these. If you have any questions, please feel free to give me an email.